This is a demonstration of extracting volumes from solids to be used as compartments in FloCAD. Here is a space claim drawing of a mocha pot. As an overview, I will switch to a section mode and click on the Y-axis to display the interior of this mocha pot. Basically, water is heated in the lower compartment and pushed upward through the filter funnel, through the top column where it falls into the collector compartment, which is the top half of the pot. This drawing has a lot of detail which is not required for my FloCAD model, so the first thing I did was clean up geometry and defeature it using the Repair and Prepare tools in SpaceClaim. Here is the cleaned up drawing. You can see I removed the lid, handle, and some of the small surfaces. My first task here is to extract volumes which I can then use to define compartments in FloCAD. When extracting volumes, I need to decide how many compartments I need and how many bays each compartment will have. For this sample, I know I need a compartment for the base volume and a separate compartment for the collector volume. Since the two volumes will have separate fluid levels, I cannot make a single compartment with two bays. Instead, these will have to be separate compartments. Using the Structures tab on the left, I will hide the base in the funnel section which contains the coffee grounds, leaving just the collector and the column in place. If I rotate this, you will see there is a hole in the bottom which allows coffee to flow up from the funnel through the center column and spill out into the collector. To start with, I need to extract the volume of the collector. This volume will be defined as the volume within the inner wall surfaces of the collector, excluding the column and the volume within the column. To extract a volume, I need to move to the Prepare tab where you can see there is a Volume Extract option. If I click on this, I now have options to select faces that will be set as boundaries or seal an enclosed volume, and another option to select edges, which will define the enclosed volume. The volume I want to extract is bounded by the top edge of the column and the top edge of the collector pot, so I will select both of those. Note that I do not need to select all the interior surfaces, just the surfaces which bound the openings in the volume. Next, I need to provide SpaceClaim a reference for the inside of the volume. This is called the seed face. Here, I will click on one of the interior surfaces of the collector wall and then click on the check icon to let SpaceClaim know I've completed the selection process. My volume is now completed and the walls have automatically been set to be transparent. If I turn off the visibility for the collector and the column, I can now see just the volume. Rotate it and you can see where the column comes up through the center of this volume. Next, I wish to create the volume for the base. I will turn off the visibility of this volume I just created and turn on the base and filter funnel visibility. If I make the base transparent, you can see the filter funnel set inside. Rotate to view from the bottom and you can see that the volume I need to extract is defined by the interior walls of the base and the exterior walls of the filter. This base compartment is a bit more complex since it is enclosed, which means I have no exterior surfaces I can click on to define the space. The only bounding surface for my volume is the bottom edge of the funnel, which is internal to the solid. The first time I did this, I extracted the inner volume of the base and then created a separate volume based on the exterior surface of the funnel. I then subtracted the funnel volume from the base volume. I later found a much simpler process. If I hover over a surface in SpaceClaim, the nearest surface will highlight. In this mode, if I use the scroll wheel on my mouse, I can move through the object to select different surfaces. The outer bottom surface, the inner bottom surface, the inner back surface, or the outer backside surface. If I place my cursor over the base edge of the funnel, I can scroll through selecting the various surfaces, such as the outer surface, the inner surface, and then I can manage to find the funnel base surface, which I will click on to select. Using the same process as before, I select an inner surface to be the seed surface and then click the check icon to complete the process, and my volume is now extracted. If I turn off the visibility of the base in the funnel, you can now see just the volume. Rotate and you can see where the funnel fits down into this volume. These are just a couple of the volumes extracted for this sample problem. The same methods can be used to extract any other volumes which were required. As you have seen, volume extraction can be very simple once you understand the concept of selecting the bounding surfaces.